Welcome to the second video in our 3-2 video series. We are going to continue discussing the rate of change. Now we are going to be talking about two different types of rate of change in this unit. With our linear functions, we are going to have a constant rate of change, meaning that values increase or decrease at the same rate over a period of time. This also means that no matter where you look at the graph, the rate of change will be exactly the same. So if we're looking at this graph, the graph is always going up by the exact same amount. It's going to be a straight line. However, when we look at exponential and quadratic rates of change, they're going to have what we're going to call variable rates of change. This means that the graph of the function will be steeper in some places than in others. And when calculating average rate of change for these functions, they will have to give us a specific interval that we're looking at. With a linear function, we can look anywhere on the graph since it's always going to be the same. But for an exponential and a quadratic, we're going to have to take a look at a specific interval. Otherwise, we're going to get different answers depending on where we're looking. So let's go ahead and look at how to find these straight from a graph. So for example 2a, we're looking at a linear function. We don't have to be given an interval because it's going to be a constant rate of change. So we just need to pick any 2 points, and we have to figure out what our slope is going to be. So I'm going to pick 2 points that look like they are on very easy to locate points. It looks like that's a good one, and that's a good one. And I'm going to be looking at my difference in my rise over my difference in my run. Alright, so it looks like I'm going up 2, so that's a rise of 2, and I'm going up, so that's going to be positive. And I'm going to the right 1, 2, 3, 4, 5. And you can kind of draw a little triangle to help you illustrate this. You can see we went up 2 and right 5. Now if we're going to the right, that is positive, so our slope is 2/5. Now when I jump over to example 2b with the quadratic, I'm going to have to look at the specific interval that they're giving me. And they're going to give us the interval in interval notation. This is telling me that I'm using the x value 0 and the x value 2. This is actually not an ordered pair. This is two different x values, 0 and 2. So what I need to do is I need to locate these x values on the graph. So I'm first going to look at x equals 0. If I get x equals 0, I'm going to go down until I hit my line, my quadratic function. And I'm going to put a dot right there. Alright, then I'm going to do the same thing for x equals 2. I'm going to count over 2, and I'm going to go up until I hit the graph. Now these are the 2 points that I'm going to use to figure out my slope, my rise over my run. So I'm going to see what difference we have. So I'm going up 1, 2, 3, 4. It was positive because we're going up. And I'm going to check out my run, which is over 1, 2. I went to the right again, so this was positive. That gives me 4 over 2. I want to reduce my fraction. That's going to be a slope of 2. Alright, that wraps up the difference between constant and variable change. You guys go ahead and give the U-Tries an attempt. Check your answers and come back and visit us in the next video.